Hey everyone, this is community code review, and in the community code review, we go through Aiken. We learn Aiken together by writing code together and going through Aiken courses together. And today we'll be going through the Aiken course hosted by the Andamio platform. So let me share my screen and start off. And today we have Ahmad with us. Um, so let's start. Okay, let me minimize this. Okay. So last time we left off right here in the previous lesson. We left off at the previous lesson, which is writing a success test case. Now we'll start with writing a failing test case. Hey, Ahmed, I have a question. Did you already finish doing this course?
Not really. I had a little hiccup trying to like get the NFT
Yeah, yeah,
to be
yeah.
able to sign it. Yeah, but I was able to see that I think 3 days ago with the pre-board. And yeah,
Okay,
I'm
cool,
hoping
cool,
to
cool.
start here.
Yeah, yeah. I think it's a good way to start this course because this course is like super simple, and once you get through this course, I feel like you'll be ready to write like some big validators and stuff like that. So anyway, so we are trying to write a failing test case today. So yeah, are you familiar with writing failing test cases, Ahmed?
Yeah.
You're writing? Okay, cool, cool. So let's go through this. I think you'll this chapter will be like pretty easy for you. Let's go through this. So it
Yeah.
says, why should we write a failing test case? Remember that when testing a spending validator, we must ask the question, will this validator allow transaction to spend funds exactly as intended? The context of this test is a transaction. We must be certain that our code will validate good transactions and invalidate bad ones. We can write failing test cases to make sure our validator prevents validation for undesired transactions. Okay. Um, Second test, transaction failure case. So I'll quickly open this transaction failure case. Is this what they're talking about? I think this is it. Failed test always succeeds spend validator. So this is a failing test. Okay. Do you have access to this folder, Ahmed?
Yeah, I have it open there in my
All right, perfect,
office.
perfect. Then we can work through this together. Let's see what they're asking us to do. In the second test, we defined a specific script context like this. Okay, so this is the script context. This is the script context. Um, Script context is imported from Aiken standard library. Okay, so I think I have the Aiken standard library open. Hey, Ahmad, are you familiar with script context? Do you have any idea what script context is?
Not exactly familiar.
Okay, okay.
Yeah.
So let's see what exactly script context is because I also have to like research this a little better. Let's see. So this is I'm in the standard library for Aiken. Let's see what script context is. Script context is a type, okay? A context given to a script by the Cardano ledger when being executed. Okay, so this is given to the validator when we send a transaction. Okay. So the context contains information about the entire transaction that contains the script. Okay. The transaction may also contain other scripts. To distinguish between multiple scripts, the script context contains a script info, which indicates which script or for what purpose the transaction is being executed. Okay. And the constructor is script context and it has three fields. One is the transaction, and the other one is the redeemer. I'm guessing this redeemer is directly from the transaction. Okay, but the redeemer field and the info field, which is of the type script info. Okay, let's see this. Script info characterizes the script information. The main and only difference with script purpose and script info is resides in the spending variant, which here contains a second field, which is datum optional. Oh, so here spending variant datum optional is added here. Otherwise, this is exactly the same as script purpose. I'm gonna open script purpose as well, just to make sure. So this is the script purpose. So script purpose is like a bunch of, seems like a mixture of constructors. So these are different types. Okay. So script purpose has all of these, except the spending one has like an extra thing, which is the datum. Okay, cool. Okay, that makes sense. Um, and I want to see the redeemers as well. Is this redeemer? I want to check this redeemer type. Redeemer type should technically just be data. Okay, I thought so. Fine. One more thing I want to quickly check is that this redeemer is not exactly the same as the transaction is the same as redeemer. Is there a redeemer section here? Redeemer section. Okay, so this is different. So this is a pair that contains the script purpose and redeemer. So there's, okay, so for a specific script, we will provide the exact redeemer that it needs to interact with in that specific scenario. Okay, cool, cool. I think that makes sense to me. Is this making sense to you, Ahmed? Script
Yeah,
purpose.
it's
Mhm.
very cool. Yeah.
Okay, cool, cool. So now let's go back to this. What they are saying is script context is imported from Aiken standard library. Okay, perfect. Uh, in this transaction context, we can define a script info type. And in this case, they have given a minting type. Why am I saying they've given a minting type? Because it literally mentions a minting type here. Let's see why they pick minting type in the first place. At the top of this list, you see minting and spending constructors. The rest of the list shows the other validator types you can build with Aiken. Why should this transaction fail? In our test, the value passed to info is minting. Okay, the value passed to info is minting. This means that we are testing what will happen if we try to use the always succeeds.spend validator to mint a token. Okay, we do not want to allow this. So we want to confirm that this test will fail. Okay, so they're basically saying always succeeds validator is a spend validator, as we can see. But there is an else section here. The else section is what gets activated when you give a different different script purpose outside of spend. Okay, so let's see if this will fail. So he put info, and like we thought, always succeeds dot else, and then they pass the context. Okay, so my question is, they have, so this is a failing test, and always succeeds dot else should fail. Okay. Um, so this is a question I had last time as well. Why is there like a not like this thing here? I think we tested this last time, but I want to redo this because I don't remember what happened. So let's test this. Is this going to fail or succeed? Um, for this, we'll have to do Aiken check M, and I am going to copy this test and I'm going to paste it here. And then what happened? Did it pass? Okay, so it did pass. But my question is, so here is how I'm thinking about this. When you pass this context minting to else, it should always fail, correct?
Yes.
Um, so
I think
so
what if
okay,
we pass it directly to So they spend and nothing else.
Correct, correct. So where I am getting confused is this doesn't say false, it says fail. So I'm trying to figure out what is the difference between fail and false. You know, what will happen if I put false here? Will this test, and let me save this, Command S, and let me try this one more time. So unknown, false. Oh, uh, so I cannot put false. I have to say fail. So I wonder what fail even does. What is the difference? Fail. I'm going to see what the fail keyword even is. I really want to know that. So let's see. Fail, fail. So it's not here. So maybe I can check in the built-ins for fail. Uh, I don't see fail head stand prelude. So I don't know what this keyword fail is. And where will I even find it? I would have thought this would be in built-ins. Fail keyword. Maybe I'll go to Aiken, Aiken language and check if I can find the keyword fail somewhere. Defaults to fail, else fail. Definition keyword. Non-exhaustive defaults to fail when not explicitly defined. I want to see what the fail keyword even means. Config model on this page. Keyboard datum. Fail.
It,
Fail keyword. Yes, this is what I want.
you've seen it, right? Let's go down a bit. Wait, slow down.
Fail definition, a test modifier annotation for tests and property based tests that expects the test to always fail. Okay, this I we understood. Handy to write negative test scenarios from functions that fail and do not. Okay, but this is, we already know this part because where is that? This is what they are saying. This is the fail, but I am trying to figure out in this context what it means. um Related fail property based test. Okay, fail once finally. uh Fail keyword. Okay, keyword that immediately halts validation execution, causing the validator to reject the transaction. Can include an optional message, does not produce a compilation warning unlike to do. Okay, so when, okay, I can say fail, but not false. What is the difference between fail and false? So it creates a what error? Rejects, causing the validation to reject the transaction. Halt the validator execution and reject the transaction. So what would be the difference? What is false? False is just a bool. Maybe it's a type.
Yeah, it also looks like if are using this for evaluation of sufficient.
What was that, Ahmad?
I said I feel like false false is like a boolean that we could use to evaluate some certain conditions. You know,
Hmm.
I just feel
Okay.
like maybe fail is a little bit just an agent.
Yeah, yeah, yeah. So, tell me one thing, Ahmad. Here, they used a not symbol before this, right? Why do you think they did that? Like, what is the purpose of this not symbol? Oh, because Because this always, okay, that makes sense. Okay, okay, okay. Because this always produces a false or
Always.
fail, and they are saying not is like, oh, what is this? They're saying, oh, it should not fail because we need it to pass. Because we already said fail, we need it to pass.
Yeah. So
Okay,
we
okay,
can
that makes sense.
we can try it out now. We maybe the not sign and also test it to see if it
Yeah,
shows.
let's see. Yeah, let's see that. Okay. Let's see what happens. Now I'm going to save this because, okay, I saved it. What happened? The test still passed. The validator crashed prematurely and the test passed.
But
Wait, what happens when I already put this? One second. So the test passed again. So the not symbol doesn't do anything?
I don't think it does anything else because there's really no
Uh,
difference. The same message.
yeah, that's what I'm looking, big. So it premature. Did I save this? I feel like something has to be different. I don't understand. I'm gonna try it one more time. So okay, it passed. I'm going to take this off one last time. I'm going to save this. Okay, I saved it. Uh, so it's failing anyway. No, what does even not fail mean? Maybe they'll explain it in the course. Let me see. Let's see if they say anything about it in the course. Is this visible, by the way? Is it too small? Let me make this bigger.
No, it's fine. It's fine.
Okay. Yeah. Why should this transaction fail? In our test, the value passed is minting. That's fine. This means that we are testing what will happen if we try to use the always succeed spend validator to mint a token. We do not want to allow this. So we want to confirm that this test will fail. Okay. But they don't explain anything about fail and why they use like a not symbol and stuff like that. Did they use not symbol here? Okay, they did use not symbol. In the second test, we define script context like this to make sure our validator prevents validation for undesired transactions. The context of it we must set in our code will validate good transaction and invalidate bad ones. I am not sure actually like what that specific thing is doing and why or why not. Um,
As to
uh, okay, so this, what does not fail even mean? I understand not true or not false becomes like the opposite, but what is the opposite of not fail? Like, what is the opposite of fail? Not fail, like it will stop from failing. Is that like a real thing? um I don't know. I don't know how to use the fail keyword like with the not symbol at all.
yeah,
Because uh-huh.
it's really not there's no trace or there's actually no difference from the both results.
Exactly,
So
exactly.
it's
That's
kind of hard to pinpoint anything like that.
Yeah, that's right. That's right. So for now, this is my assumption to move forward. We cannot, there's no point in using the not symbol with fail because if something fails, it fails. We can't prevent it from not failing. So
Yeah.
that's my assumption for now. And we'll move forward with the lesson. We'll come back to this if someone knows the answer, or maybe we can try to figure it out like after the
Yeah,
session.
yeah, yeah.
Cool.
Yeah. Sure.
Okay, so let's go to the next one. This is pretty clear, right? Why the failing test case and all of that, writing the fail part in front of the after the test and all
Yeah,
of that.
yeah.
Okay, cool. Let's see what is the next one. Mm, Okay, always succeeds minting validator. Lesson context. Now that you have seen how to write, test, and compile a spending validator, let's look at an example of a minting validator. Okay. Uh, Open the file validators module 102 always succeeds mint. So module 102 always succeeds mint. Always succeeds mint. Okay. Let's see. Okay. I'm gonna close this guy. Okay. What is it saying? Okay, we have opened this. Things to notice. Line 1 and 2 are import statements. We know that. Line 8, 1 and 2 are import statements. Line 8 is the name of the validator. We are calling it always succeeds. Um, Line 9 is the purpose of this validator, and the purpose of the validator is mint. And we have already seen like script purposes. Script purposes, mint is the script purpose, and the constructor is the mint keyword with the policy ID. So let's see if it is following that. So it mints and it is getting the policy ID, but along with the policy ID, it is getting a couple of other parameters. One is the redeemer parameter, policy ID, and the transaction. And these guys are always like constant when you run mint. And it is saying true. So that means anyone can mint this token using this validator.
Yep.
Okay, that seems pretty straightforward. But if we give a different script context, it'll fail because the else fail will be activated. Okay, cool. That seems pretty straightforward. Let's see what they're saying next. Every validator type accepts a different set of parameters. Every validator, okay, of course, every validator type accepts a different set of parameters. On line 9, you can see the parameters for this minting validator, okay, which is the same thing that we saw, redeemer, policy ID, transaction, okay.
Yeah.
Line 10 is the return value of this validator. A validator should always return a boolean true or false. If the validator returns true, then it will allow a transaction to be built or accepts the transaction. If it returns false, it will not validate the transaction. This validator always returns true, which means that it will allow tokens to be minted at any time by anyone, okay, which is what we discussed. Sometimes you will define parameters without using them. In this case, our validator returns true no matter what the value of the redeemer, policy ID, and transaction are. That is why all of these parameters names start with an underscore. Okay. Because we are not using any of these three parameters in our logic,
Yeah.
we just put that underscore on up there. Okay.
Just to ignore the.
Yes. The underscore tells Aiken to ignore these variables. Try removing the underscore and run Aiken checks. Okay, we'll try that. We'll remove just the underscore for redeemer. Save this file. Uh, and then we'll run a quick test. I'm going to clear this. And I'm gonna copy always succeeds. If I copy always succeeds, I think a bunch of tests will get. That's fine. I can check and always succeeds. Okay, how many did we always succeed spent? Always succeeds mint, and we have one passed test. Wait, it passed. Did it not give me any warnings? Oh, it did say warnings. It warns us. Yeah, unused identifier redeemer. No big deal, but you might want to remove it or use a discard redeemer to get rid of that warning. You let binding, okay. So I don't necessarily have to use underscore, like because I still see that it is getting compiled. You know what I'm saying?
Yeah, it's just like the one that okay, you have social parameters and you're not making use of it in any of your logic. So just to be comfortable.
Exactly, exactly. So
Yeah,
it's
I
just a
guess
warning.
it's
Mm-hmm.
yeah, yeah, yeah. It's not it's useful when you start writing a lot of logic and you might not be able to keep track of a lot of this stuff that you've passed in. Maybe you probably forgot to include it. So just a like a helpful stuff, I guess.
Yep, yep, yep. I agree. And also, you know what else I think? I think when you put an underscore here, it will save resources because um, the more logic, the more resources a validator consumes, the costlier the transaction to run this validator will be. So if we put an underscore, this is again just my assumption. I have a feeling it will not consider this redeemer and it will save us memory, which will make our transaction cheaper, I think. That's what I think, but it is not 100% confirmed. Will we know how many resources it consumed? Maybe,
So
oh,
this
here it is,
200. Yeah.
216.1K. Let's try it now with this thing, and let's see if anything different happens or not. Nope, nothing different happened. So CPU
Yeah,
16.1K.
I
Yep,
guess
nothing.
because either way we are not we're not making use of it as as a logic in our
Oh,
purpose. Yeah. So,
I see, I see, I see. So, like in the when this like did this, I want to see read what this is saying. It is saying no big deal, but you might want to remove or discard redeemer to get rid of the warning. Okay. You should also know that unlike in typical imperative languages, unused let bindings are fully ignored in Aiken. Okay. They will not produce any side effects such as error calls. Programs with or without unused variables are semantically equivalent. Okay. If you do want to enforce some side effects, use expect with a discard underscore redeemer instead of let. But we didn't use any let bindings, right? Here? No, we didn't use any let bindings. Okay. Mm, expect with a discard. Okay. So if I want it to be specifically discarded, I can use expect underscore redeemer. Okay, cool. Makes sense. Okay, cool. Makes sense. Compare the spending and minting validators. Look at the parameters in the minting validator and compare them to the parameters used in the spending validator from lesson 102.1. Okay, let's do that. So I'm going to quickly close this guy and I'm going to open this. So in the spending validator, where is it? We have four parameters. One is the datum, redeemer, input, which is of the type output reference, and the transaction. But for the minting, we only have redeemer, policy
yeah.
ID, and the transaction. So yeah, did they say datum? No datum. Okay, so just okay. So in this, the datum and input are like the difference for a spending validator. Cool. Okay, makes sense. As you can see, for each validator purpose, there's a different set of parameters. We'll investigate these parameters in depth in module 202 and 203. Okay, that's fine. Um, Step by step, writing, testing, and compiling a minting validator. Okay, write the validator. Once again, this validator code is provided. Step 2, test the validator. What is the test? I haven't seen the test yet. This test is always succeeds dot mint. And what did they say? For the redeemer, they said void. Okay. For the policy ID, it's an empty policy ID. And the transaction, they just gave a placeholder transaction. Okay, cool. And our test passed anyway, right? I remember our test passing. Yeah, our test passed. Okay, that makes sense. That was expected anyway. Okay, cool. To run this test, try this. What did they say? Aiken check M102 test always succeed minting. Okay, of course. Yeah. Step 3, compile the validator. To compile all validators, use the command Aiken build. Okay. And then okay, use the okay, you okay. Hey Ahmad, I have a question for you. If I want to
It's,
find the policy ID created by this validator, where would I find it? And how will I get it?
um, I think my biggest guess is we'll have to build the validator
Okay. And how will I build the
and
validator? What should I type?
Aiken build.
Aiken build.
Aiken.
Okay. I did Aiken build. Okay. I think we have passed everything without errors. That's fine. We have some warnings, but that's fine. Okay. Now what will I do?
So yeah, we have like a Plutus JSON file.
This one? Okay. We have
Yeah.
the plutus.json file. Okay. Where is the, what would
So
I
we are
do
going to
next?
just so we are dealing with like the main thing validator.
Minting validator, spend. Okay. Always
So,
succeeds mint. Okay. Yes. And then,
okay. So I think this is just like a guess. Uh,
mhm,
our policy ID will have to be like the hash of
this one
yeah.
right here.
Yes.
That's correct. That is the policy ID. So the hash of the compiled code of a minting validator becomes its policy ID. Yeah. Uh, so, and the same hash is used to build the address as well if it's a spending validator. So if a validator has both like minting and spending in it, this will become like the policy ID, minting policy
For
ID.
both
Yeah.
for both
And then
purposes.
we'll build the address for that also using this hash. Okay, that makes sense. I think Ahmad got it. Ahmad knows what this is all about. And that's exactly what this step is saying. Compiling the validator, you have to run Aiken build. And once you have Aiken build, you have the plutus.json. And step 4, use the validator. Let's see what they mean by use the validator. In lesson 102.1, you learned how to build an address for a spending validator, correct? For our minting validator, we are not really interested in creating a spending address. Instead, we want to derive a minting policy from this validator. Okay. Use this command to generate a minting policy from the always succeeds minting validator. Okay. Aiken blueprint policy something something mint. Okay, let's try this and let's check if our assumption is correct or not. Um,
Yeah.
let me clear this. Aiken blueprint policy. Okay. Ooh, what is this? One error. Hmm. Module 102. Always succeeds dot mint. I didn't find any validator matching your criteria. Really?
I think it provided us with the accurate file path. You can see on the modules.
Module
And the one of
102. Oh, because we have to say validators.
yes.
Okay, let's try that then. Uh, okay. Validators slash. I think we have the same error. Uh, so they're saying, please narrow the selection using additional options. Okay. Oh, we have to say,
Yeah.
are we supposed to say dot? What did we, 1 second, let me see. Always succeeds dot in your file module validator and how are mm,
I think we're not supposed
I,
to pass the purple. Maybe that's no.
you know what, I think we shouldn't use the dot. I'm going to do this and see. uh, oh, try running Aiken new repository to initiate a project with example manifest files. Are we in the main? So we are in main. So do we have the manifest? Aiken.toml is here. Aiken PBL examples. Okay, that's fine. I I feel like there's something we're missing here. Just like in terms of what I will do is policy. Okay, I'm going to say help and see what it'll say. Dash dash help. So it is saying, oh, dash dash validator, and then you provide the validator. Uh, so you give the module. Uh, oh, so maybe I'll just say, wait a minute, dash v, and maybe I'll just give it always succeeds, always succeeds mint. Wait a minute. What is going on? I'm gonna say dash dash of here and see what it says. Oh, so the module. Okay, I feel like I've done this before. So you have to first provide the module separately and then provide the. Okay, got it. Okay, got it. Got it. So dash M, let's give it the module. What is the module? Where's the module? I feel like this is always succeeds mint. This is the module. Let's copy this. And after that, provide the validator, which is dot always succeed. Do you think this will succeed or not, Ahmed?
I'm very, very scared too. I don't know.
Let's see. Oh, it succeeded. Yay. So
Yay,
we have
wow, that's
this.
great.
Yeah. 088 EA is what we have.
Yeah, I think that's
077
same
EA.
with what we saw in
It
what we
is the
saw
same
in
thing.
little
Let's see.
validation. Yeah,
088 EA. Oh, okay. So our assumption is correct that the hash is the policy ID. Okay, cool. Okay, cool. And also we learned that M is for module and V is for validator when you're using this. So maybe this is
yeah,
outdated.
that's a new thing. Yeah.
Yes. So, okay. So this is outdated. We'll have to let the people who wrote this know that this is outdated.
Yeah, yes.
Okay, cool. Um, it is only possible to mint tokens with the policy ID by using our always succeeds minting validator. Of course, that may not be what we really want. Instead of allowing anyone anywhere to mint the tokens anytime, we probably want to set some clearer rules for how and when new tokens can be minted. Okay. That is what Aiken allows you to do. Now that you have seen some basic validators, you are ready to continue this course. Go to assignment. Let's do this assignment. Okay, I'm excited for the assignment.
Wow.
Um, Ahmad, you also do it from your side. I'll also do it from my side. And I'll be talking through my logic. Let's see how we do this. Okay. Assignment details, neat and tough stuff. Now that you are ready to and put this, make sure you just like save this somewhere if you're doing it on your side, so that whenever you do this course, you can directly put the assignment and then submit it, and then you can get the
Yeah,
credential for this course.
awesome.
Um,
Okay.
yeah. So now this is a challenging assignment, and we think you can figure it out. If you get stuck, bring your questions to Aiken PBL. Well, we are already in Aiken PBL. Um, define a custom type. Okay, let's do this. Where should I do my assignments? Write a test to show that. Define a custom type for datum and another for redeemer. Okay. Write a spending validator that succeeds when datum and redeemer have these two type signatures but fails otherwise. Write test to show that your validator works as expected. Okay, let's do this. I am going to, in the validators itself, I'm going to create another folder called assignments. I'm gonna call it like a small letter assignments. And in this, I'll start creating this assignment. What should I call this assignment? 102. 102. Okay. I'll call it ASSIGN 102.8K. Okay. Okay. Um, let's see. So what is the first request? It is saying define a custom type for datum and another for redeemer. And as we already know, defining custom types, let's see. So this is how we define custom types. You give it a keyword name for the constructor. No, it become this is the name of the type and this is the name of the constructor.
Yeah.
But if both of
So
them are the same, yeah, yeah. Go ahead,
yeah,
Ahmed.
so we can decide to use any other thing for.
Yeah, whatever we want, whatever we want.
We can say okay.
Yeah, yeah. I'm going to be using some random name, like say for example, let me try this. So it says type datum, right? And what was the request again? It is define a custom type for datum. Okay. So I'm going to say type um datum um datum one, doesn't matter, some random datum. And does it need anything? Maybe I will say datum should have one field. I'm gonna call the field name and I'll call it an int. Actually, it'll be easier. Okay. So this is my custom datum. Uh, so I just created a custom type for datum and I only use datum like this because I only have one constructor in it. That is why I just use datum. So the constructor and the name of the type are the same thing. But if I want to have two different constructors, I will be using it this way. So say for example,
Okay,
if
my
I want,
God.
yeah,
So yeah, I follow the data constructor and passing it to yeah.
so I'll calling it datum one and I'll be calling it datum two. This is just like um and I'll remove this. It'll be count and say signer, or I'll just say name just to make it easier. But now I have two separate names. Then I'll have to define it like this because this will be the constructor for this type. Datum one will be the constructor for the first type, and datum two will be the constructor for the second version of datum. But if I only have one, I'd much rather go with the first way of doing it, which is just this one.
Yeah, this is
Okay,
easier to read on that.
exactly, exactly. So, and what is the second thing they asked us to do? And another for redeemer. Okay, let's write a random redeemer type redeemer one. This will also be name. Okay, we have that. Why is int? Oh, maybe int is like a integer is not a type. Maybe is integer not a type? Let's
I
see
think we
primitive
have to
types.
put things with a capital R.
Oh, is it? Is that how it is? Ah, I see. Oh, I see. I see. Oh. What is this? I discovered an okay, unused is fine because we haven't yet used it. Okay, cool. So Ahmed corrected me. So when you're using the primitive types, you have to use a capital letter to use this integer type. Okay, so we did that. We defined a custom type for datum and redeemer. They are saying write a spending validator that succeeds when datum and redeemer have these type signatures, but fail otherwise. Write a spending value that succeeds when datum and redeemer have this type signatures. Okay, let's do this.
Okay.
So to define a validator, we start with a validator keyword, validator, and I'm gonna call it assignment 102. Will it be confusing because the name of my file is also the same thing? So I'm just gonna call it assignment one, ASSIGN one, and what kind of validator is this? It is a spending validator. Why is
Spending
it a
money.
spending validator? Because that's what they asked.
Yeah.
Okay, so this is the script purpose next. Spend, right? And this is standard, by the way. Datum, redeemer,
Within
input, and transaction are standard. So I'm just gonna take them as is.
yep.
I'm gonna put this like this. And at the end of this, what I'm going to do is I'm going to put an
Yes.
else,
Yep.
fail, because I don't want any other script purpose to pass outside of spend. So that's why I put
Yeah.
the else below. Okay, so we have that. I wish I could. Is there a way to like make this nicer? Uh, Something like this. Let me see if I say, okay, beautiful. Oh, output reference. I found a reference to an unknown type. Maybe we'll have to import that type. Let's import it. So to import, we have to use the use keyword. Oh, Cardano trans. Maybe that works. Let's see. Okay, so output reference. Ooh, what happened now? Output reference. I imported output reference from Cardano slash transaction. And what is this? I caught a private value trying to escape. What is this?
Uh, I think this is where you have to use like the pub keyword as well. This
Uh,
is kind of complete.
what was that, Ahmed?
Um,
We have to use what?
the pub keywords. Um,
Oh, public. Oh, like, but this is in the, I thought the public keyword was for using it in a different file. Let's see. Maybe, maybe it is the public keyword. We'll see. Pub type. Pub type. Okay, let's see if that resolves this. That's right. So you have to use the public keyword even if it's in the same file. I thought the public keyword was for different files. Okay, cool. Thank you, Ahmed. Okay, so we use the public keyword. And we have datum, which is optional, redeemer, which is of the type 1, input, which is of the type output reference, and the transaction. Okay. So what are they saying next? But fails otherwise. Write test show you. Okay. So what I should do right now is I want to do this. I'm doing that because I want to use the datum and redeemer in our logic. So what I'll do in this is I want to use the expect keyword. I want to do that. And I'll use the expect keyword for redeemer. And that's it. Actually, I don't even have to use the name. I just need to make sure they're of the same type, right? So I will put, so I don't even have, do I have to do that? Expect some datum. So I was, uh, what is going on here? I struggle to unify the types of these two. Express redeemer one, which is a name, is equal to redeemer. is equal to datum. Okay. Can I just put underscore here inside? I wonder because I don't care for what comes here. Okay. Okay. What is this? Hmm. Looking for one of the following patterns. Let's see. Uh, Actually, what if I'm mm, so let's see. Expect some. So we are basically unwrapping this and we are saying there will definitely be some datum present and it will be of the type datum one, but the name of the field I don't particularly care. So when I do this, for example, when I say name, and here also when I say name, I basically am trying to say that I want to use this name field later on in the logic. But if I don't want name field, what would I do? Mm,
I wonder if we can understand the name as well. Is
what was that? What was that, Ahmad?
I wonder if we can also be like an underscore the
Un-
name
un-
to see if we can also discard it like that. Like
like,
underscore name.
can you post it in the chat so that, oh, did you post something? Mm, oh, can you post in the chat so that I can like copy paste it? Um, let's see. What is this going on? So I mean, I can do this, then it'll all be nice, I think. Oh, what is this? Expect if you're driving one constructor, unless you're casting from data, you can let bind. Oh, so I'll have to put name one and name two here, and then I'll have to say name one and name two. Then it should be fine. This is fine. But what if I don't want to do this? How will I do it if I don't particularly care to do this? Okay, Ahmad suggested something. I wonder if we can do this underscore name to discard it as. Oh, let's try that. Yeah. So let's see underscore name and underscore name here. And I'm going to remove this guy. Ooh, now we are getting. Oh, and then, yeah, of course, it has to end with true. That's right. How did I forget that? But it is saying I'm looking for one of the following patterns. Why is it looking for one of the following patterns? And do you know what I wonder? I feel like underscore doesn't work here. Let's do this. Let's do this. I'm gonna say trace at name one. Okay, I'm gonna do that. So the reason I'm doing that is because I have a feeling the whole variable is just called underscore name one, underscore name two. You know what I'm saying? Instead of underscore meaning, yeah. Uh, that's what I think, but we'll test it out. But this is where I'm confused. What is this asking? I'm looking for one of the following patterns it's saying. I found an unexpected token is equal to. What does that mean? Um, uh, So one more thing is when when you are calling the spend script purpose and you are defining the purpose, sorry, defining the types here itself. Um, Is there like some enforcement here? Like if you're already defining the types here, should we say, should we recheck the types here at all? Or can we just say true and it'll, let's try it out. I actually want to try that out. Like what will
Yeah.
happen? Let me write a test for this. I'm going to save this. Let's see. So to do the test, I'll have the test keyword. Let's see. Assignment 102 test success case. Let datum is equal to some datum name one. Okay. Assign one spend datum redeemer. Okay. That all seems good. So I defined the datum. I defined the redeemer. What's going on here? Um, so since we haven't used datum or redeemer in the, this will again be, I think, like a always succeeds spend validator
Yeah.
because we
Because
haven't used it.
returning to
So we have to use this somehow in the logic. I'm just thinking, how will we do that? Maybe we should do this. Let's see. Maybe we should do uh, when keyword when datum comma redeemer is, yeah, that's what I want to do, equal, this will give true, otherwise false or fail. I mean, yeah, I think false is fine. So this is a success case. Let's test like a test a fail case, and let's use the keyword fail. Datum double, wait, so I don't want to say this, I want to say some data, right? So I don't have to have the correct one. So I'll give it the wrong type. Oh, I'll change the types. I will put the redeemer type here and the datum type here. But I'll have to change the sum part. Let me do that. Okay. So I basically changed the datum and the redeemer part. I tripped over some unknown labels. I don't know what this means in a pattern or function. I don't know what it is saying. Do I have any issues anywhere? I don't see anything. Okay. Um, okay, so I called this. Okay. Let's see what happens. I have no idea what happens. So I will clear this. I can check M and I'm going to try this one. Oops. So it gave me an error. The error is the error is in the validator itself, line 19, which is this. So it is saying there's something wrong with this. What is wrong with this? What is name one? I'm gonna put underscore here now. I'm gonna put underscore here. I'm gonna save this and gonna clear this and try it one more time. Oops, so it still doesn't understand the underscore. Okay. What is it saying? What is the error it is saying? Oh, Aiken Toml demands compiler version 1, but you're using 1.19. Is that like an issue?
No,
Aiken
I know
Tomo.
that that.
Oof.
I think you just
I'm just gonna change this then. 1.19, right? Does it matter? Does it matter if I change it? Compiler version, dependencies, Sedan Labs, vodka. Vodka I don't need. So I'm gonna save this. Can I directly change Aiken Tomal or not? I don't know. We'll see. I'll clear it. Okay, so okay. So I don't see the previous error anymore. So it's just saying compiling Gimbalabs Aiken PBL 0.0.0. What is that? Okay, that's fine. But it is saying I found an unexpected token underscore. Okay. So how do I say that I don't care for what's inside? Datum one is the name. Hmm. What was that, Ahmed?
usually expect keyword. Okay.
Expect
Maybe we
keyword.
say expect. Yeah.
Uh, but is this but expect keyword is kind of same as like when is right? When datum and redeemer is this
Yeah.
and
Yeah.
this, it'll be the same, I think. Um, so even when we use, say, for example, if I do this and just say we previously we used the expect keyword, right? Expect some datum and some redeemer and true, which is what we previously did. We were getting
Yeah.
this issue. Remember, I'm looking for one of the following patterns. What is this? What does this mean? Equal to, okay. Or what if I said expect datum equal to this instead of, and no, no what? Expect datum is, oh, I can say that directly. Oh, that's cool. But it's still giving us an error. What is this? And similarly, if I say expect redeemer is redeemer one, and just put an underscore. Okay, is keyword. Oh, so there's nothing called is. So it just like randomly, I think my AI suggested some random thing. Uh, okay, so if there's no is, see, I don't understand this. So why can't I do this again? Why is this being sketchy? Following patterns. Oh, maybe I think this is a star. Is it star? Let's see. Oh, no, it's not a star. Hmm. Mm, how do we use this? Uh, did you have any success, Ahmad?
Not really.
Yeah, you're also trying. Okay, let's figure this
Yeah,
out.
I'm also trying. Yeah.
Okay, cool, cool. Okay, let's keep trying. Um, okay, let's see. So if I can't use this, how will I do this? So what if I just say name one and like previously name two? What will happen now? So now it is going away. Now let me try this. So I think it's an underscore issue. Mm, let me try the success test case. Oof, it is still complaining. What is it complaining about? It is saying name one. Here's a list of all the valid labels that I know of. Oh, it's saying name. So what happens if I just do name for both? But can there be two variables with like different values? It makes no sense. Um, name is equal to name. Okay, let's see this. Hmm, unknown variable, mock UTXO reference. Okay, so I'll have to use. Okay, that's fine. I got that guy. Let's try it one more time. Placeholder. Oh, I'll have to use placeholder as well. So I'll have to use transaction Cardano placeholder. Okay, all is good. Now let's try. Now it is saying expected type some datum. What did I put here? Datum is equal to. I already put that though. Datum. Wait, why is it saying that? I already put some. I struggle to unify the type of two expressions. Oh, so it will not allow me to put like a different type. Okay, cool. So what I'll do is, I'll have to go back to this one. Okay. And retriever one. I'm gonna call this like a string. Aiken. Doesn't matter. Oof. Okay, so I'll just have to do one. Uh, how do I if this is supposed to fail, what are we saying? Like, no big deal, but you might want to remove it or use a discarded name underscore name. Oh, maybe you're right, Ahmad. You see this? You see this warning?
Yeah.
If I linger on this, it's saying, but you might want to remove it or use discard underscore name to get rid of that warning. You should also know that unlike in typical imperative languages, unused let bindings are fully ignored, blah blah blah, that let bindings. They'll not produce any sense. Okay, maybe you're right. Let's do that. Let's put underscore in front of it. and see if the warning goes away. Okay. The warning did go away, but we are ending up this issue.
So why is that happening?
Yeah, that's what I'm trying to figure out. What is going on? Let me actually just try to run this and see what happens. Uh, how do I do this? How can I write a failing test? I don't even, I can't figure out how to write a failing test because it's not letting me write a test if the types are wrong, you know? Ah. Actually, you know what? You know what I want to do? I want to do this. I'm gonna call this Redeemer. I'm gonna call this Redeemer 1 and Redeemer 2 and see what happens. Mm, okay, this has taken care of that. Let's see. One of the
Yeah,
following
that error.
patterns. Ugh. Hmm. I found an unexpected token, comma, Redeemer. What is
Oh,
like? Why is it
okay.
focusing on the?
I think the comma.
Yeah, let's see how these guys have defined it. Um, Custom types. Uh, oh, multiple constructors. Type bool. Logged in. Okay, so it doesn't need the comma. Okay, cool. So it doesn't need the comma. Okay. Okay. Now let's try it. Oops. What is equal to datum? I'm looking for one of the following patterns. It's saying unexpected equal to. Mm, Hmm. I'm gonna clear this for now. Let's see. Let's try this one more time. Actually, let me try this once. Because I have a feeling this might work. Instead of underscore, I'll call it underscore name. And similarly, I'll call it underscore name. Oh, already has an issue. None of the following patterns. Unexpected token underscore name. Okay. So I cannot use underscore name. Hmm. So maybe not this. Let's try this. Nope. That's what I want. Hmm. How can we use this? This doesn't make much. So I'm trying and gonna charge my. Let's see. I'm gonna call just to try some things name one and then call this name two. Okay. Okay, let's see. Hmm. Oh, this is really my one. That's right. Hmm. It is giving some really good feedback right now. Okay. So it is saying, so I managed to make at least the first successful test work. Um, but I used a bunch of unused variables. Um, and the first test passed as it should, and the second test should have failed. Like because the second test and first test are exactly the same. This one should have failed, but this test didn't even go through. I can't figure out. Oh, because it didn't go through because yeah, yeah. So this test will fail now because I'm going to put this uh fail. This test is going to fail. I hope it failed. Oh, there it is. It failed. It should have. So how do I make this failing test pass? I can't figure this out. How do I make this failing test pass? Mm. And by the way, Ahmad, I just put these two names with the name with like random names and it passed. But these are unused variables. And when I put underscore in front of it, it's not letting me put underscore in front of it because it is giving me this error. So I'm not too sure what's going on there. Uh, so if this passes, I feel like this should also pass this way of doing things. I'm gonna call this name one and name two. I'm gonna save this. Okay, I feel like this should also pass. Let's see. Okay, this also passed now.
Yeah.
Okay, now let's do the failing test, which should this failing test should fail instead of passing. Okay. Okay, so both of these methods worked, Ahmad. Oh, where's the other method? The expect method. It removed the. Array, why did it remove it like that? Okay. Okay.
Make the field test, I guess.
What was that, Ahmad?
No, I said, how do we now make the field test
Yeah,
pass?
that's what I'm trying to figure out. Like, how do we make the fail test without it crashing? Because it immediately crashes when I change something here. Um, how do we do this? And what was the assignment, by the way? Did they ask us to make a fail test? Write test to show that your validator works as, I mean, technically we are showing that our validator works
Yeah.
as expected. Um, oh, so maybe just to make a fail test, I think we should just put this. And then it should technically pass. Let's see if the test passes.
Okay.
So it passed.
Wow.
But I feel like I'm cheating. I mean, even though the test passes, I feel like um but I guess it is like a reasonable way to do this assignment, but I still want to know how to make
Wow.
these, yeah, make these like I don't care for these variables. How do I do this? No big deal. And it also suggests this, right? Underscore. But when I put underscore,
Yeah.
it is saying I can't do it, and I don't
It
understand
doesn't
why.
work.
Yeah, let me try one last time to put underscore and see what happens. Immediately, see, I found an unexpected token.
Unexpected thing. Ah.
What is this? Like, what do I do? Uh, Um, if do they put star? Oh, oh, I think I remember what they do. I think I remember what they do. Oh, now I remember. Yes, I remember what people do. Yes. Okay.
Oh,
Now I think
so
it
this
should
is
pass. Uh-huh.
oh, like the spread. Uh,
Yeah, they just use the spread thing and then it becomes like, hey, I don't care for it. Okay. Now let's try
wow.
this. Okay. So okay, the failing test passed. Now let's try the success case. Okay, that also passed.
That
Now
was that's
let's try the same thing here. I'm
mm,
gonna get this and do the same thing and do the same thing. And let's see if this passes. Success case. Okay, it passed. Okay, I think the spread
mm,
operator is what we need to do. Specifically, right now, I don't know how to think about when to use this underscore, but for now, I think the underscore should be used
for
when,
parameters.
yeah, for the parameters, but when you're actually
Yeah.
using it inside the logic, I'm guessing it is the spread operator. But that is a guess for now until something changes and we get to know some different things. But how do
Yeah.
you feel about this, Ahmed? Do you feel good about this assignment?
Yeah, I am. I feel good actually.
Okay, cool.
uh,
Uh-huh.
yeah. I was able to like for example, this spread. This is like my first time seeing it. I didn't know it exists. You know.
Yeah, yeah, yeah. I completely forgot about the spread operator because I remember the transaction pipe people using it, and then I never used it, and now I finally got to use it. I think I'll remember the
Oh,
spread operator better now. Um,
All right.
okay, I think it is how I think it's almost 12. So yeah, it's been an hour and a half. But thank you so much, Ahmad. And for this week's class, you'll be getting paid 75 ADA, which is like the payment for like co-hosting. So both of us
Oh,
will get 75 ADA. Is that cool with you?
yeah, that's fine. Thank you.
Okay, perfect, perfect. All
Yeah.
right, I'm going to stop the recording.